Well, good morning, YouTube. All right, guys, today we are working on the off-grid solar system that I've been installing in Goliath once again. So if you saw the previous videos where we installed the Multi-Plus 2, the bus bar, the DC to DC charger, and all the wiring is one to go there. The second episode, we did the solar charge controller and rewired the solar and installed the Servo GX device to monitor everything from the inside. And I had mentioned that my goals still were to upgrade the batteries and upgrade the actual solar panels themselves. Well, today we're going to be working on the batteries. Not sure I'm going to put them yet. I've got two batteries right here in these boxes. Let me open them up and show you what we got. Now, I know people really like these unboxing videos. So, I took a sneak peek, but I'll show you. It's pretty simple. It's just a cardboard box and a piece of foam, a little bit of paperwork, and then behold, a battery. I'll need two hands to pull it out, so hold on a second. All right, guys, and there we go. We are using the Chins 12 volt 300 amp hour batteries. Not just one, but look, there's another box. We're doing two. Now, guys, I decided to use the Chins battery because I've done a lot of research online, and there's a lot of different battery companies out there. And in fact, there's a lot that are rebranded, but Chins seems to be, as far as a pre-made large amp hour rated battery, Chins has got a good reputation, good build quality. I've watched some of the other YouTubers like David POZ and William Prowse. In fact, William has torn these things apart a number of times, and he really nitpicks them apart. And I like the build quality on this. He liked the build quality on this, and I'm very picky about stuff like that. So for the money, I think this is probably about the best battery that you could get to just have a drop-in battery and not build it yourself. And I hate to say it, but even watching some of the videos on how to build your own battery bank using just the raw cells, buying your own BMS, you almost can't do it as cheap as you can here. Yeah, you can save a little bit. What's all said and done, for my application, this is what I thought was going to work the best. And while I am limited on space on Goliath, and I wanted something that was just going to work. Now, using these Chins batteries is going to be a huge upgrade to what we've already got installed. And for those of you that are new to the channel, here's what we've got so far. So right now I have a bank of 4 interstate 6 volt golf cart type batteries. And of course they are lead acid, and you see all the problems we have with corrosion, and I just cleaned these up a couple of weeks ago. Looks like yeah, we're having some issues here no matter what. The batteries are swollen. They've been over discharged a number of times already. They just don't have the capacity that I need, and they're crazy heavy. Now, speaking of heavy, these Chins batteries are not light. They weigh about 75 pounds, give or take. But it's not as heavy as 4 of these lead acid batteries. And one of them has more than double the actual usable capacity than what this bank here has. So all in all, yes, I'm going to be saving weight by going to this rather than having an equivalent power bank with lead acid. Oh wow, guys, and look at this. This is new. Look at that. It actually melted through the battery housing right there. That is not a good thing. You can see the melting here. This wasn't like this very long ago. This is new, and I know exactly what happened. So when we're running off of the inverter, I typically turn off the breakers for the air conditioning, the water heater, and I just let the low amp draw devices stay on. So we've got lights, we've got the refrigerator, we can brew coffee if we want to, but we still don't do all of that all at one time. We're very conservative because this battery bank was very limited. Now, the inverter we have is a 3,000 watt pass-through inverter. So what happened was when we were Ocean City last week, we were hooked up to the generator that was supplied by the event coordinator on a 50 amp split phase circuit. We had one air conditioning going, and then in the morning we turned on the coffee pot. Katie's oxygen generator was still running, which doesn't draw a super amount of power, but it's about 500 watts or so continuous. Sometimes it'll spike up to about 7, but usually 550. Well, the problem is the generator that we were hooked to quit working. And this is one of the problems with the automatic inverter system that I see, if you're not paying attention, is that when that generator stopped working, we had no idea inside. because everything worked so smooth and seamless with this multi-plus that we never saw a problem until the light started to flicker. And then I went and I checked the monitor, and our power was down to like 70 something percent. The Servo GX actually sets an alarm in there, and it told me that we had lost power probably, I think it was like 13 minutes before I had noticed it. So in that 13 minutes, the air conditioner, the coffee pot, her oxygen generator, plus a few lights and a couple fans were all still running off of inverter power, which this battery bank wasn't designed to work with. So I almost wish that there was a much louder alarm or something when the power was cut, something to let me know without a doubt that we have lost our shore power. That way I can make sure to turn off those high loads. So obviously we draw more current than these batteries and these battery cables can handle, but we're gonna fix that when we put the new batteries in. These batteries can discharge at a much higher rate than these batteries can, and they're just gonna work better all around. On top of that, we are going to be getting rid of those rooftop ACs and putting in mini splits. So even if the AC was on, we won't be drawing nowhere near as high of a load. All right guys, so now my question is, where do I put these new batteries? The two of them together, I think, are too big to fit on that tray. I've got the space underneath the tray, or I can just move the batteries over here and get rid of my electrical cords and my garden hose, and I can put that stuff over here, because I do plan on expanding this battery bank still from this at some point. This is still kind of a test to see how well this works. Now keep in mind, this is 600 amp hours, and for what we do, we're not full-time off-grid people. We're not going out to courtside and staying out there for months at a time. You know, we need that overnight, sometimes 2 or 3 days, where we're not plugged into power in between shows, to try to avoid having to go to campsites and stuff like that. So I think this will work. I mean, you know, these batteries here ran the fridge for a good 10-12 hours without any issues whatsoever. So with like 5.5 to 6 times the capacity of what we had, realistically, there shouldn't be a problem going a day or two if we don't have the opportunity to plug into power, and we want to minimize using that generator as much as possible. So I may even take out this tray, and then I can build something that'll just stack the batteries. And if I turn them sideways, so they go here to here, I might be able to fit 2 deep and fit a total of 4 in there at some point, which will give me 1200 amp hours. Or I can move them down to here and just lay them in this area so that all of the solar stuff, everything is in the one compartment. Don't know if that's a good idea or not. You know, with the lithium, there's no off-gassing, so putting them in the same compartment isn't necessarily a bad thing. I've watched a lot of YouTube videos where people are doing that, and it doesn't seem to be a problem. With the lead acid, I definitely did not want them all in the same compartment, because these things corrode and they cause corrosion and everything around them. In fact, you can see that tray and how nasty the tray is. So I think with the lithium, I can do that. So I'm gonna have to do some measurements and find out exactly what I wanna do and how I wanna do it. Plus, I'm gonna need to reprogram the solar charge controller. I'm gonna need to reprogram the DC to DC converter. And I'm also gonna need to reprogram the Multi-Plus 2 for the lithium charging protocols. All right guys, so I'm gonna take some measurements and I'm gonna do some math and I'm gonna come up with a plan. I've got a little bit of time still, because since these batteries are both brand new out of the box, what I need to do is make sure they are at an absolutely full charge. So I need to charge each battery individually till they are 100%. And then I'm gonna wire the two together in parallel with no loads so that they can just balance each other out for at least 12 hours. That's what the battery manufacturer recommends. That gives me time to figure out what I'm gonna do here and where I'm gonna move things. And that way, when these are done and ready to go, I can just move in, put them in place. All right guys, one more thing too here. I failed to mention that these are the Smart Chins batteries, which means that the BMS that's inside the battery, and for those of you that aren't familiar with lithium technology batteries, most good batteries have got a BMS installed on top of them. It's a battery management system. It monitors the individual cells. It controls basically the rate of charge and discharge, and if it finds anything wrong, it can shut the system down to prevent fires or explosions and other bad things from happening. So both of these batteries have Bluetooth capabilities. So here I'm going to switch to a screen recording and be going into the app. So I had to download the app onto my phone and then connect the two batteries, and if I can do it, you can do it. It's pretty simple. but you can actually monitor the state of charge, the voltage, everything like that within the batteries, even the battery temperature, so that any given time, I know what the status of each individual battery is. So you'll see here that there's a serial number, and this one ends in 118. Apparently the one in the other box that I have not even opened yet is 114, because it picked it up on the Bluetooth, and I've got them both programmed in. All right guys, so that's how the app works, and I did some measurements, and it looks like I can fit both batteries on that tray if I turn them sideways and run them lengthwise. There's just about ½ inch of clearance all the way around, so that's probably what I will do for now, instead of running them into this compartment way over here. But I'm not going to do that today, only because I did not bring the laptop with me. In order to reprogram the Multi+2 to be able to charge the lithium technology, I need to plug in with a laptop and change the parameters within. And I did not bring the laptop with me today because I thought I was going to be able to do that from the Servo GX devices mounted inside, but I tried and it doesn't give me access to those settings. But at least now I know where it's going to go, what I'm going to do. So tomorrow I'm going to come up with a computer. I will hook one of these batteries up directly to the Multi+2. We will disconnect all of the loads. I will reprogram it, and then we're going to use the Multi+2 as a charger only to just charge the one battery. And when it is 100% fully charged, we'll disconnect that battery, plug in the second battery, and get it 100% charged. And then we'll let them both rest for about 12 hours. And then I will connect them together in parallel for about 12 hours. And at that point, I can install the system in here, and the Multi+ will charge them. They will all be balanced. They will all be even. Then I'll just need to go into the DC to DC charger and the solar charge controller and change those to the lithium parameters as well. Well guys, it's like 2 days later, and I finally found the USB adapter that hooks to the laptop, which I'll show you. That is right here. I've got it sitting right up at the top of the battery. So with that, I can plug in to the Mac here, and that's also plugged into the inverter. And I was able to go in and just change those parameters for what this particular battery requires for proper charging. Now I had a little bit of trouble figuring it out, and I meant to screen record it as I was doing it, but I was kind of watching another tutorial at the same time. Remember, I'm not good with computers, so this was a couple-hour process. Even once I found my my adapter there, it took a while for me to figure out how to get into the computer and actually get everything changed. But it looks like it's all changed now. So I've got it all set up for lithium battery parameters. I put a max charge voltage, absorption voltage of 14.6. That way everything can fully top charge and be perfect. So right now this battery's in there, and according to this, it is charging at 91 amps. The current voltage is 13.76. Now, you guys remember that earlier clip, these are only like 44 or 47% charged when I received them. So we will get this battery 100% up to charge. Then we're gonna switch the batteries out, get the other one 100% charged. Right now I have the inverter in charger only mode, so we're not running any loads off of it. We are plugged into the generator because I don't have a cord long enough to reach over to the building. And the only plug I've got access to in that building is a GFI outlet, and the inverter and the GFI outlet, they don't get along very well. So we're going to run the generator just to charge up these batteries and get them right. So it's going to take a few hours to charge up. We'll switch it, charge up the other one, and at that point, we're going to let them all settle and balance before we do the final installation. I mentioned we're not running any load, so what I've done is I've taken the battery cables coming out of the inverter, and they are going straight to this battery. So I've basically completely disconnected the entirety of the rest of the system. There is nothing else there. And the main reason for that was just to isolate the battery so that it gets a 100% charge with no loads on it. All right guys, so just a little teaser here. Not for this video, for another one, but why those batteries are charging up. I've got my mini split system here as well. And I've got to do some modifications to the interior back in the bedroom of Goliath to get this wall unit up there. But just a teaser, because from now on, what I record, it's going to be for a whole nother video. All right, guys, here we are. It's about 7:30 p.m. now, and I've had that battery on charge for quite a few hours. It finally went through the bulk stage into the absorption stage, and I did have to adjust the parameters a little bit because I had the absorption set at 14.6, but it turns out that is the high voltage cutoff for the BMS, so it kept turning off the charger and then turning it back on once the voltage dropped. So I reset that parameter to 14.55 volts, and then the absorption charge seems to work very well to get at that absolute high point. It then went into the absorption mode after that, and then it went into the float mode. So this battery is 100% charged, as you can see on this little screenshot here with the battery app. Some of the individual cells are still off a little bit more than I think they should be, but at this point we're going to disconnect this battery, put the other battery in its place, and do the same thing. All right, guys, it is the next morning and we're back up here at Goliath. Now, in the last clip, what you saw was about 7:30 in the evening. The one battery was fully charged, and I was over here putting the second battery on charge to get them both up to their peak. What you didn't see is that, I went home, had dinner, watched a couple YouTube videos, played with the grandkids, and then came back up here at like 11:15 at night to check and see if that second battery had reached its float mode yet. And it hadn't, but it was in absorption mode. And so I figured, well, you know what? The absorption time is only set for about 1 hour. I had no idea how long it had been in absorption mode already at that point. But I just figured I'd sit here and hang out and wait for it. And then something went wrong. I think it's just because I need to tweak the parameters a little bit on the charger, because for some reason, I guess it reached its voltage limit. It shut the battery off. And when it does that, the inverter shuts down. It took a few moments for the inverter to turn back on after the battery reset, and then it went back into charging mode. But what happened is it went into a bulk mode for just a few moments, and I don't know why. It started drawing like 80 amps, even though it was already in absorption mode. It shouldn't have, so I'm not quite sure about that part yet. Remember, still learning this stuff. But then it went back into the absorption mode, but then the timer started all over again. So I literally sat here for over an hour waiting for that. So it was about 1 o'clock in the morning by the time I disconnected that battery, put the generator away, and went back home to go to bed. All right, so what I'm going to do now is we're going to go into the app and we're going to compare the two batteries, make sure that the voltage is right, the individual cell voltage is kind of where I want them. As you saw in one of those other clips, they're a little bit further off than what I would think would be okay. Based on what little bit of knowledge I have, it may be fine. But so here, we're going to go in and do that right now. All right, guys, so now that we've verified that, what we're going to do is we're going to hook the two batteries in parallel. So we're going to hook the positive to the positive, the negative to the negative, and we're just going to let them sit here for the next 12 hours so that they can balance to each other. And after that, we should be ready to do the final installation on it. All right, guys, just for temporary, just use a set of jumper cables to run the two batteries together for balancing purposes. Remember, no load going through these, so for balancing, this will do the trick. We'll let that sit for at least 12 hours. And then we will do the final installation. But I still need to make up battery cables to go here, but I want to get them actually in their place first and make sure that they all fit exactly before doing that. That way, if I need to adjust the length on them, I can. All right, guys, it is the next day, and these two Chins 300 amp hour batteries have been tied together in a parallel for more than 24 hours now. So if there's any balancing to be done, it should have already been done. I'm going to go ahead and disconnect these jumper cables from them, and then we're going to go into the app and see if the app shows that they've been balanced the way that I think that they should be. It looks like they have balanced out pretty well. Looking at the individual cells, the average cell voltage was pretty much right on par with one another. So at this point, I feel confident going ahead and adding these batteries to the system. But first, we got to get rid of these broken down lead acid batteries and make room for these. And then I'm gonna have to make some cables to connect the two batteries in parallel. And I do have some 4/0 cable, which is probably overkill for this, but it's what I've got right now. I had to go out and get some terminals, and we should make this happen. Well guys, I don't know if you can tell by the time lapse. I got the batteries out of there, and of course I had to do a lot of scraping and cleaning because there was some battery acid residue in there. And of course, lead acid batteries, they're causing this tray here to rust pretty bad. And truth is, I don't know how much longer I would trust it with some heavy lead acid batteries on it. And I do intend on changing this setup. I just don't know exactly how I want to do it yet. But because we're going to lithium, it's going to be a little bit lighter than what we had on there. We're going to live with it for a little bit longer until I decide what we're going to do here. So now let's see if we can fit these new ones in. All right guys, and you can see they just fit in there pretty nice. Only have a little bit of room left here, a little bit on the sides. There's just enough clearance on the ends that I'm going to take a piece of rubber or something and put down in there just so that these bolts don't rub on the sides of the batteries any. But that's probably how they're going to sit in there. My battery terminals, the leads should reach up here very nicely. I think that'll work. All right guys, so here I'm kind of laying out the 4/0 cable, and yeah, truth is 4/0 is probably a little bigger than what I need. It's kind of overkill. You know, when it comes to stuff like this, you really can't go too big. The larger cable you use, the least amount of resistance is going to be in the line, so you're less likely to overheat anything. It doesn't hurt to go too big, it just hurts to go too small. All right guys, so I've marked it with a piece of tape where I want it. And as you can see, I'm leaving quite a bit of excess on here, only because I want to have some room to be able to maneuver these batteries. Or in the future, if I need to replace an end or something like that, I've got the room to do so without having to make whole new cables. And there's a good reason for that. Well, part of that is because I made a mistake in planning. Yeah, absolutely 100% my fault. So the lugs that need to go on the end of here, I thought I had some left over from the original install, and apparently I do not. So I went out locally and I found some lugs to fit 4/0 cable. The problem is the battery terminal bolts on these chins use an 8mm bolt. The only thing I could find has a 1/2" hole in it. So these lugs are technically going to be too big, but they're going to work for now. We're not drawing any really high loads on it at this point. So I have every intention of ordering the right ones and getting them here so that I can replace them. But for now, I have to use this because I have to get these batteries up and running. I didn't want to keep running with those compromised batteries, especially once I saw that it had melted a hole in the terminal and it was open. Just not a good thing. So these have got to get in before we leave for Myrtle Beach tomorrow. So this is what it's going to get for now. And if I have to, I'll use a little washer or something in there, which I know is not the right way to do it, but it will make do for the moment until I can do it correctly. Again, while I'm leaving the extra length there so I can shorten them to put new terminals on in the future. All right, guys, when I built the rest of the system, I didn't really have a good crimper to crimp all these things. What I did this time is I came into the shop and I've got this 20-ton press here, and I used this V-block die. But what I did is I used this V-block die right here, and I laid the cable in here, indexed everything properly, and then I took this bolt right up here on top, and as I pressed it down, you know, the V in this crimped and made a very nice looking connection. Anyway, this is our end result, and I think it came out pretty good. All right, guys, here is the finished product. Now I got a little bit of overlap on there because of the way I've got those cables long, but that will get cleaned up when I shorten them. I did cut a piece of rubber mat and I put it in here, and that actually takes away all of the side-to-side movement that was in there. And for right now, I've just got them held down with a strap. There are lips around the trays. That will keep everything from moving. And just so you know, none of these batteries were tied down at all. They were just sitting in there. Goliath has a complete air ride suspension. It's a 4-bag on the back and 2 bags on the front. So even though we hit bumps and it kind of floats, we don't really get the jarring bumps. So we've never had a problem with these batteries moving around, but I know that tying it down is the right way to do it. So now they are tied down. All I've got left to do now is hook up the inverter again and then reprogram the other 2 chargers. Remember, we already programmed the inverter, even though I think I'm going to go in there and lower the absorption rate down to 14.4 because I think that's what these are rated at instead of 14.55. but I need to make those same settings in the solar charge controller and in the DC to DC charge controller. Now, what I did on these connections that were too big is I had these copper crush washers, and these are actually for drain plugs on motorcycles and whatnot, but I found a couple of them that were a very tight fit into the hole in the battery terminals. Like I couldn't put them in there by hand, but when you crank them down with the screw, it actually forced them in there and took up all that slack, and it's also copper, so it should provide good connectivity. We shouldn't have any issues with anything. Everything's nice and tight, everything is secure, and then when I get the right terminal ends, we'll just obviously eliminate that. All right guys, all the power's turned back on. The DC to DC charger has been reset, the solar charger has been reset, and the Victron Multi+ 2 has all been reset. That is going to be it for now. All right guys, and it is now a couple of days later. In fact, we were supposed to be in Myrtle Beach by now, but as you guys know, we had to cancel that trip. One thing, as I watched that last clip, I noticed that I forgot to do, and it puzzled me the next morning until I realized what had happened is I never reset the parameters in the battery monitor. So the shunt of the system measures all the power coming in or out of the batteries in the system and monitors everything and puts it up on the display. So even though I changed all of the charging algorithms to suit the needs of these batteries, what I didn't do was tell the shunt that I put a much larger battery bank in here. So it was programmed for a 200 amp hour battery when now I've got a 600 amp hour battery in there. So, you know, overnight the voltage dropped a little bit, the stated charge dropped just because, you know, things like the doorbell dinger, the microwave, whatever. And I came back in the next morning and it was down to, I don't know, like 93% or something like that. And I thought, wow, there really wasn't any loads. I expected it to be a higher percentage than that. And it's because it thought it was still a smaller battery. So I have just corrected all that. I changed all that in the settings for the battery shunt. So now we'll be able to get a good, honest measurement of how well these batteries are going to do over time. And well, guys, I think this is going to end this video on getting these Chins batteries set up and put in here. You know, converting from lead acid to lithium was a huge step in this system to work, and it was a new technology. The learning curve has been a little bit challenging for me, but I hope you guys enjoyed it. Thank you for watching, and until the next time I see you, keep those engines running. And in this case, keep those batteries charging.